I'm sure if you listen carefully, you can follow. So this array, we want to do selection sort. How to do selection sort? Okay. So we will go through a number of steps to sort this array in ascending order. So initially, we will start from here. Start from first position. So that means start from index 0. So what we do is here, over here is that initially we will start from here and we go through the array, to find out which one is the smallest element. Okay? Check all the elements. And to see which one is the smallest. In this case, this is the smallest, right? This is the smallest. Then after you identify the smallest element, then you will swap the first element with the smaller element. We swap them. Swap these two elements. So the smallest element will become the first element. And the original first element will take the position of the smallest element. That's the first step. Swap them. Then this one go to the first element, and here 14 go there. Okay. After you do that, that means we complete one step. Okay. So certainly there will be question on sorting. Yeah. When you are asked to do sorting, you have to show every step correctly. Yeah. If you have to show every step, ask you to do a selection sort, you must show. If it's a 7 step, you must show 7 steps. Every step you must show correct result. If you ask to do selection sort, if it's 7 steps, you only show 5, 6 steps. Your answer is wrong. That is very strict. Okay? So now this is considered one step. We start from first element. Yeah, one step. So after the first step, the smallest element is in position. So and the first element is sorted. So after you start sorting, the array will be divided into two parts, the sorted part and unsorted part. Now, after you finish one step, this part is sorted. The sorted part only have one element. And how many altogether? How many elements? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. So that means the unsorted part of 9 elements. These are unsorted part. After you finish, so the sorted part is this one. So if you are asked to show the result of the first step, so you should show this one. Every number should show correctly. This is the first step of selection sort. So selection sort, every step you select the next smallest number. The first step, you select the smallest number in all the number in the array. Okay, so after this, we shorten the list by 1. That means the unsorted part, the size reduced by 1. Initially, the unsorted part is 10 number. Okay. Now, after you finish step 1, the first element is sorted. So the unsorted part become 9 elements. Then after that, you do the same thing again for the unsorted part. This unsorted part, we do the same thing. That means we find the smallest here. You find the smallest in this part and bring it to the first position of the unsorted part. Bring it to here. Okay. So now, what's the smallest? Which one is the smallest? 6. 6 is the smallest. So you will swap 20 with 6. 20 with 6. Okay? 20 is here. In the unsorted part now, we swap these two elements. 20 with 6. 6 go here, 20 go there. Okay, after this you complete the one more step, second step, complete the second step. So when you complete the second step, again, the sorted part, in front this part is sorted. Sorted part increased by 1 element and unsorted part reduced by 1 element. So this is the result of the second step. if you're asked to show the result, second step, yeah, you have to show this, exactly according to this array. Then after that, you will continue to do the same thing for the unsorted part. It means do the same thing for this part. Okay, now the unsorted part, the first element of the unsorted part is here, right? Here. So again, you will check through the unsorted part to find out the smallest value. In this case, what is the smallest value? Smallest value is 7, right? So 7 is already in position, so you don't need to swap. If it's in position, you don't need to swap. Okay? So 7 itself is the smallest, no need to swap in this case. So now, but after, that means we have completed the second or third step. Again, the list is sorted. The unsorted part is sorted by 1 again. So now 7 is here. This is the sorted part, and the unsorted part is here. And continue. Okay, continue again, do the same thing again. For the unsorted part, every time you check the unsorted part and find out the smallest element, you swap with the first element in the unsorted part. Okay? So by doing so, the unsorted part will become smaller and smaller. Okay, now this step don't need to swap. Yeah. So sorted by 1 again. Okay, so this is the way every step. This is the result of every step. Okay, so this slide shows the result of every step. Now we are not going to go through every step, go through in detail every step. Okay, so you continue until here. So how many steps we have to do? 1, 2, 3, 4, 5, 6, 7, 8, 9. This array has 10 elements. So the number of steps you have to carry out is 9. Why is 9? Okay, so you do one step for one element, keep moving, right? One, second step, third step, fourth step, fifth step, sixth step, seventh step, eighth step, ninth step, right? 9 steps here. So once you finish the 9th step for selecting sort, that means you have completed, you have finished. Why is finished? Because the unsorted part is one element. One element. One element, the smallest element in one element is the element itself, because it's just one. Yeah. So don't need to move. So when you, for selection sort, once the unsorted part is left with one element, straight away you can stop. Yeah. That is the indication that you have finished. Yeah. So altogether, you have, for an array of 10 elements, you have to carry out 9 steps. Okay? And every step, yeah, the sorted part will be extended with one element. Unsorted part will be reduced by one element. So all done here. How difficult the problem is, okay? So, so just now we did not go through the detail of finding the smallest one, right? We just visually, just visually see that it's the smallest one and swap with the first element in the unsorted part, right? We didn't really go into detail on how to find the smallest one, right? So finding the smallest one also requires a lot of effort. We have to keep comparing. Okay, let's say this case. We want to find the smallest one. Let's say this is the unsorted part. Now we come to this step. This is the unsorted part. This step means 1, 2, 3, 4, 5, 6. We have completed the 6th step. Now we want to proceed to the 7th step. 7th step, the unsorted part here, sorted part here. So now we need to find the smallest element here. Okay? So how to find the smallest element? This is the standard method. To find the smallest one, initially you will set the smallest to 18, set to this one. You assume that the first one is smaller. Then you will keep comparing the next one with 18. Compare 18 with 17, 18. First, you will set the smallest, assume that the first one is the smallest. Then after that, you will compare the current smallest with the next element. So in this case, 18, the current smallest is larger than the array element, right? So that means you have to update. Yeah. So that means the smallest is not 18, it's 17. You have to update to 17. Okay. So firstly you will set to the first element, and after that you keep compare until the end. Okay. So you have to compare with every element. Then smaller, the next element is smaller, so you have to update the smallest to 17. It's no longer, then when you update, you have to keep track of the index. Next. Okay, next you will compare with the next one. Next one is 20, right? 20 is larger than the current smallest. So if the array element is larger, that means you don't need to update the smallest. The current smallest remain unchanged, still the smallest. Okay, so still 17. Then after that, after compare this one, you compare to the next one, 15. Compare 17 and 15. 15 is smaller than 17, right? So for this case, since the array element is smaller than the current smallest, so you will have to update smallest to 15. Update smallest. So now you have reached the last element. You will compare with the last element. Okay? So that means you will compare with all the elements now. Now we can conclude that the smallest is 15. And when after you update smallest, not only the value, you also have to update. You have to keep, normally you have to keep track of two things. The value of the smallest and also the index of the smallest. In this case, the index is 9. Okay? So you have to keep that index. So after that, you can sort them. You can swap this element and this one. Only you have the index, then you can swap. Okay? So now the smallest is. So there's a lot of comparison. Okay? In other words, here how many comparisons we do? 1, 2, 3, 4 elements only. So we need to do, initially we set to this value, so we need to do 3 comparisons, right? Compare 18 with 17, compare 18 with 20, right? Compare 18 with 15. So if the unsorted part is 4 elements, you have 3 comparisons. You need to compare 3 times. Okay? So there's quite a number of comparisons for this particular step. But initially, when we get the first step, we start from first number here. Okay? How many comparisons you have to do for the first step? Here got 1, 2, 3, 4, 5, 6, 7, 8, 9. Altogether 10 elements. So first step, how many comparisons you have to do in order to find the smallest? First step, the whole array is unsorted, right? It's altogether 10 elements. So how many elements you have to compare? You always set the smallest to the first element, then after that, you compare the current smallest with the rest of the element, right? So how many comparisons you have to do for the first step? 8. 1, 2, you have to compare 5 with this one, right? Then compare 5 with, after that you have to compare with this one, and compare this one, compare this one. 9, right? Yeah. You have to compare with 9. So the first step you have to compare, you have to do 9 comparisons. Yeah. Likewise, the second step you have to do 8 comparisons. Accordingly, the third step you have to do 7 comparisons. And the last step, you have to do, the last step means you left with only, you are here. So you only do 1 comparison. So in this case, that means the first step you have to do 9 comparisons, and after the 8 comparisons, 7 comparisons, etc. Right? So you have to do a lot of comparisons. Yeah. So in general, after comparison, you find the smallest, you have to sort. But there will be cases that if the smallest is exactly the first element in the unsorted part, you don't need to swap. You can save the swap. But comparison, you cannot go without it. Definitely have to do. Then you swap. Yeah. So this is okay. In order to, we are talking about in terms of how to carry out sorting. But since we have discussed the detail of selection sort, so now we bridge the concept and theory with how to practice it. To practice it means, since now we have studied the method for selection sort, can we write an algorithm for selection sort? Yes, we can write algorithm for selection sort. This is an algorithm for selection sort. Yeah. Okay, so we start from for array n element, the last index is n minus 1, right? N minus 1. So how many steps here? So we start from, we start from index 0, right? Your first element index 0, and until the second last element, right? Second last element, the index is n minus 2, right? So every iteration of this for loop is the task that we do for one step. Okay? So every iteration will complete one step. Every iteration of for loop will complete one step. So if the array, just now the array we have seen is how many elements? 10 elements, right? So 10 elements, so 10 minus 2, it means from 0 to 8, right? From 0 to index 0 to index 8. So altogether 9 steps, right? Just now, yeah. 0 to 8 is altogether 9. Okay, so these are the things that we do in every step. Okay. So this part is to find the smallest element. Find the small. First, we set the smallest element to the first element. To the first element in the unsorted part. If we start from initially, we start from 0, we set it to the first element, index 0. Then after that, we compare the element with every subsequent element, right? So this for loop compare with every element. Then after finish this for loop, we will mean index will be the index of the smallest element. After this for loop is completed, mean index will be the index of the smallest element. Okay, so now since we have located the smallest element, so we swap the smallest elements with the first element in the unsorted part. Okay, this is the index of the smallest element. We swap it with the first element in the unsorted part. It's AI. Swap them, so it will be in position. So this is the selection sort algorithm. You can write this. You can convert this algorithm using by writing a program. Okay, how much work? Just now we go through this. Just now we say that the first step we do 9 comparison, right? The second step we do 8 comparison. So all this add up together. The last step we do only 1 comparison. All together add up together is 45. We do 45 comparison, but every step after we locate the smallest element, we will do a swap, right? In general, we do a swap, but this is definitely, for comparison, it's fixed. Yeah. But for swap, if the element is in position, then we may not need to do swap. So the maximum number of swap is 9, but it may be lower than 9. Okay. Okay. So generalize, we generalize this case. Yeah. Also, for an array of 10 elements, this is the number we have to compare. Okay. How about array of n elements? For array of n elements, that means first step we have to do n minus 1 comparison, right? The second step we have to do n minus 2. Then do until the last step we do 1 comparison. So the number of comparison in the array of n element is this number. It's the same, it's just generalize it. So the first step, the number of comparison is always 1 less than the number of element in the array. N minus 1 for array n element. The first step we need to do this comparison, second step will be n minus 2. So this is fixed. Definitely we have to do all this comparison. So the total number of comparison will be all this add up together. 1 plus 2 plus n minus 1. Okay? So, and this sum, okay, this sum you can use a formula. This is an arithmetic series. Okay? Every term, the difference is 1. 2 and 1, the difference is 1. 3 and 2, the difference is 1. N minus 1 and n minus 2, the difference is also 1. So there's a common difference in this series. So this is arithmetic series. For arithmetic series, yeah, I tell you, I can give you a very simple formula for arithmetic series. Okay, so to calculate the sum is always the first term plus the last term. First term plus last term, and time the total number of terms. Here are we total number of terms. Altogether 1 to n minus 1. So it's n n minus 1 term. Okay. So for arithmetic series, this is arithmetic series, and the sum of arithmetic series is always first term plus last term divided by 2 times the number of terms. Okay, so for this case, first term is 1, last term is n minus 1. Divided by 2, and altogether how many terms? N minus 1 term. So you get 1 plus n minus 1, minus 1. So here n divided by 2 times n minus 1. Okay, that's why you get this. And for an array of 10 elements, the number of swap is 9. For n element, number of swap you need, because every step you need to do a swap in general. This is the maximum number of swap. It's n minus 1 swap. Okay, so that means for array of n element, you have to do a selection sort, you have to carry out this comparison, and you have to carry out this amount of swap, which is quite a lot. Okay, the sum is arithmetic. So for calculating the number of operations involved, usually we just want the approximate figure. Okay, so if we add up these two together, it's the number of operations involved in order to do selection sort. Add this and this together. Add this and this together. Okay, so when you add this and this together, how much? N times n minus 1 divided by 2 plus n minus 1. Okay, the number of operations. Okay, this is to calculate the total number of operations include swap and comparisons. So here, if you add them up together, this one will be okay. N squared minus n divided by 2 plus 2n minus 2. That means plus 2n minus 2. So then it will be n squared plus n minus 2 divided by 2. Okay, this is roughly n squared divided by 2. N squared divided by 2. Because for analyzing the number of operations, okay, so subsequently if you go for the algorithm data structure, yeah, you will study complexity. For analyzing complexity, usually we will just focus on the term with a higher degree. The term with a higher degree. Okay. So the term with a higher degree is n squared, right? So you will ignore constant and other term. We will just focus. You will just approximate. That means this is approximate to. Approximately, this is n squared divided by 2. We ignore those lower degree term because for calculating number operation required or complexity, okay, we will focus on large array. For large array, 10, let's say 10 elements, 10 squared, yeah, is very much larger comparing with 10. So that's why we say it's n squared divided by 2. Because we ignore all other terms, just only for approximate, we just look at we just consider the term with the largest degree. Okay, so now we take a look at insertion sort. Insertion sort is another basic sort. Yeah. Okay, insertion sort is quite different from selection sort. Insertion sort, we do not start from the first element. We start from the second element. The first step starts from the second element. Because insertion sort is to arrange the front part in order. The first element, there's nothing to compare. No need to arrange. It's to arrange. So initially, the first step is to start from the second element for insertion sort. Then we arrange this part in order. Okay, now it's already in order. Okay, 14, 20 is in order. That means lower very in front, larger very behind. So this is the right place. There's nothing we need to do. So the first step is finished. Okay, after the first step start from second element for insertion sort. Then you arrange first and second element in order. Okay. Let's say if this one is, if 14 is here, if 20 is here, then I will have to bring 20 here and 14 there. But now it's already in order. So we don't need to do anything. So this is the first step. So if you are given a question on insertion sort, then ask you to show the result of first step, you have to show this. So exactly according to this. Yeah. And so after the first step, these two elements, this will be the sorted part. This sorted because we arrange them in order. This is the sorted part, and this is the unsorted part. So at the end of the first step, you have your sorted part include two elements. So now we repeat the same thing. Every time we extend the sorted part by one element, that is the same with selection sort, but we do it in a different way. Yeah. Selection sort, that means every round we select the smallest element, yeah, and bring it to the front. Every round we select the smallest. That's how the name given. Selection sort is select smallest element. For insertion sort, we arrange them in order. That's why we call it insert. So the third step, we will extend by one element. That means the third step. The second step, we will extend the sorted part by one element. That means we arrange these three elements in position. So now 7 is not at the right place, right? So the second step, you will have to bring 7 in front. So the next element start at 7. So we find the right place for 7. 7 should be in front, right? 7 is lower than 14. So we will have to shift 20 and 14 to the back and move 7 here. So this is the result of the second step. After the second step, yeah, the sorted part, we have 3 elements. So the length of the sorted part always increase by 1. So we have finished this step. Okay? So if you are asked to show every step, show the result of every step of insertion sort, that means the first step you have to show this. The first step you have to show this, yeah, to indicate that these two are sorted. The second step, you will have to show this. So every step we extend the sorted part is sorted part by one element accordingly. So the third step we will extend by one element and extend to 8. So we order them here. So we will reorder here the number here so that 8 is in position. So 8 should be here, so we bring to here. So now the sorted part increased by one element and unsorted part decreased by one element. So we keep doing that, keep doing this until we reach the end of the whole array. So for instance, can we stop here? Let's look at the slide, okay? Can we stop here? When you reach, cannot, yeah. Because the concept is different. For select sort, because every round we select the smallest and put it in position. But for instant sort, is we order them. So we have to, even with one element, we have to continue. So the last step is we left with one element, so we have to put this element in position. So we have to put this one here, and shift all this backward. Okay. So after that, then everything is done. Okay. So for instant sort, is to arrange the sorted part. Every round we extend the sorted part by one element, and reduce the unsorted part by one element. So when you extend, we put the element in order. Okay. So that is the main difference between selection and instant sort. So you can see from here that for selection sort, we start from the first element, right? And we end at the second last element. The second step is to after we put the smallest in the second last, we complete. So if your array only left with one element in unsorted part, that means we can stop for selection sort. But for instant sort, you have to carry out until the end. And so the number of steps involved, is it the same? For selection and insertion sort, the number of steps, is it the same or different? The same. Although for insertion sort, you have to carry out until the last element, but don't forget that you start from second element. So if array of 9, 10 elements, that means you 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. Because you start from second element. So the number of steps is the same. Okay, so to move the element in position, after you find the location, there's still quite a number of things to do. Yeah. So now let's say here, okay, so now let's say for these steps, this is a sorted part. This is a sorted part. Now we want to extend the sorted part by one element. Let's say this under this step we want. Now we want to see the detail, comparison and movement that we have to do. So because just now we just cover the main idea. Okay. So if you are here at this step 1, 2, that means now we want to do the step number 3. We start from the second element, there's first step, there's a second step. So when you want to bring this element into position, there's a third step, right? So now we are in third step now. So we have to extend the sorted part by one element. That means we have to bring this element in position. Okay? So all we need to do is we compare this element with the preceding element. Compare this element with this element. Okay? If this element is smaller, we will keep comparing. We compare with this element. Okay. Compare this element. Then it's still smaller. Still smaller, that means we will go forward, compare this one. So now this is larger than this one. That means we will find we have found the place for 8. We have found the place for 8. So 8 should be here. 8 should be here. So after this, we will move the rest of the element. After we find the place, all these elements we have to move, shift one position to the right, shifting all to the right. Once you locate the place, then those elements in the sorted part at the right of the place, we have to shift one position backward. Shift one position backward. Okay. So and make room to insert 8. After that, 8 will be inserted. Okay. So there's a lot of comparison also. There's a lot of comparison. You may need to compare until the first element, but for certain cases you may not need to compare. If let's say, okay, so the number of comparison in this case, the maximum comparison is compare every element. So if the sorted part is 3 elements, you have to do 3 comparisons. If the sorted part is 4 elements, you have to do 4 comparisons. That's the maximum comparison. So once you have located the position for the element, then you can stop the comparisons. Find the right place and put the element there. Okay, quite a lot of move involved. Okay, so in this case, altogether there are 9 steps for 10 element array. At the maximum, that's how I say, you have to do the first step. The first step starts from second element. You only need to do 1 comparison because there's only 1 element at the sorted part. The second step, you do 2 comparisons.